Hello everyone, we are in the section Functions and Limits, and today's lesson will be the 4 ways to represent a function. Functions simply arise whenever one quantity depends on another. For example, the vertical acceleration a of the ground as measured by a seismograph during an earthquake is a function of the elapsed time t. If you look at the figure down below, you can see the x-axis is the time in seconds, and the y-axis is the acceleration in centimeters per square second, I think that is. I'm not 100% sure, but there we go. What is a function? A function f is a rule that assigns to each element x in a set D exactly one element, called f of x, in a set E. The set D is called the domain of the function. The number f of x is the value of f at x, and the range of f is the set of all possible values of f of x as x varies throughout the domain. Another way to picture a function, other than the graph form we are all used to from maybe high school or whatever subject you did, is by an arrow diagram. Each arrow connects an element of D to an element of E. The arrow indicates that f of x is associated with x, f of a is associated with a, and so on, as you can see from the diagram below. This will become useful in later subjects when it is important to visualize functions in this way. There are 4 ways to represent a function: verbally, by description in words; numerically, by a table of values; visually, by a graph; and algebraically, by an explicit formula. If a single function can be represented in all 4 ways, it's often useful to go from one representation to another to gain additional insight into the function. For example, the function is described in words. Let C of W be the cost of mailing a large envelope with weight W. The rule that the US Post Office used as of 2015 is as follows. The cost is 98 cents for up to 1 ounce, plus 21 cents for each additional ounce or less, up to 13 ounce. The table of values shown is the most convenient representation for the function, though it is possible to sketch a graph. So in words, it's not really clear how the relationship is between the C, the cost, and the weight W, but when you put it out in a table like below, it's way easier to see the relationship. And as mentioned, you could even sketch a graph, and that might even be a more clearer representation of this function. The vertical line test is used to tell if you have a function or not a function. Okay? A curve in the xy plane is the graph of a function of x if and only if no vertical line intersects the graph more than once. On the left hand side with the green tick, you can see that's a function. The vertical line passes through that function once, or graph I should say, line, whatever you want to call it, once. And on the right hand side, it passes through that graph or line twice, and thus it is not a function. And you can go back to our previous representation here, reread it with the elements and the mapping, and you will realize that this is inconsistent, and just using this definition of a function, the vertical line test is obvious consequence of that. Piecewise defined functions are functions defined by different formulas in different parts of their domains. On the left hand side, we see a function f is defined by f of x 1 minus x if x is less than or equal to -1, and f of x equals x squared if x is greater than -1. And if you've never created a graph like this or visualized it, you can see it on the right hand side. And it's important to note that little jump at -1 on the x-axis. You can see the circle is colored in. That means that value is included. And at the bottom half, you can see that circle is empty or it's not colored in. It means it's not included, and that can be clear from the left-hand definition of f of x. The absolute value of a number a, denoted by that, is the distance from a to 0 on the real number line. Distances are always positive or 0. So we have the following definition. The absolute value of a is always greater than or equal to 0 for every number a. Therefore, any number you take the absolute value of, it will never ever be 0. Okay? Important. For example, absolute value of 3 is also the absolute value of -3. They are both equal, as you can see. And there's some examples after that that follow the same rule. Alright. And if you look at the graph at the bottom, that is how you will usually graph the absolute value. And logically, it makes sense. On the one hand of the x-axis, it's symmetrical to the other hand of the x-axis. And it never drops below 0. Alright? The y value, sorry, never drops below 0, if it wasn't clear enough. If a function f satisfies f of minus x equals f of x for every number x in its domain, then f is called an even function. For instance, the function f of x equals x squared is even because f of minus x equals minus x squared, which equals x squared, which equals f of x. And on the right hand side there, you can see a graph of an even function. Then if f satisfies f of minus x equals minus f of minus x for every number x in its domain, then f is called an odd function. For example, the function f of x equals x cubed is odd because f of minus x equals minus x to the power of 3, which equals minus x3, which equals minus f of x. Alright, on the right hand side you can see the function there. A function f is called increasing on an interval I if f of x1 is less than f of x2. Whenever x1 is less than x2 in I, it is called decreasing on I if, well, the opposite, f of x1 is greater than f of x2 whenever x1 is less than x2 in I. And very important, this must hold true for every x1 and x2 in an interval I. Alright? Important to take note of. There you can see a graph of a parabola, y is equal to x squared. You can see from figure 23, right above there, that the function f of x equals x squared is decreasing on the interval minus infinity to 0, including 0, and increasing on the interval 0 to infinity, including 0 as well. Alright, that's very clear to see. Thank you for watching, and I'll see you in the next lesson.